Welcome back to Elements of Chemistry. In this episode, we're going to talk about the metric system, which is also known as the System International. The metric system's been around since the late 1700s, and it's used all around the world with the exception of the United States, Liberia, and Myanmar, which all still use the older imperial or customary system of measurement. The metric system is based on a system of standards that are available to everyone on the planet and does not rely on an arbitrary value such as the imperial system. You may have heard that the inch was based on the width of a king's thumb, the foot, his foot. Okay. The metric system is based on standards that everybody on the planet has access to, like the boiling point of water being 100. Okay. It's a really good explanation of standards, can be found at the National Institute of Standards website. And if you're a pre-AP or AP level student, I highly recommend that you go to this site and look at it. So measurements are divided into measurable values and derived values. Derived values are those that are calculated from measured values. So we have the measured value for mass. In the metric system, we use the kilogram, kg or capital Kg, and it's comparable in the imperial system to the pound. Length is the meter compared to the yard. Time is second in both systems. Temperature is Kelvin. That's the absolute temperature scale, or we'll use degrees Celsius also in metric. And that compares to Fahrenheit. Celsius compares to Fahrenheit. Kelvin will compare to what we call Rankine, hardly ever used. The amount of a substance is the mole in both systems. Electric current is the ampere in the metric system. And luminous intensity or brightness is called candela in the metric system. And it's also used candela in the imperial system. Common derived units, those that are calculated, are things like density, which is in grams per milliliter, grams per cubic centimeter. You'll have a similar thing in metric, pounds per gallon, pounds per cubic inch. Energy is the joule in metric, calorie in the customary system. And you'll most often see those on food labels. And on food labels, that would usually be in kilojoules or kilocalories. Pressure is in pascals. Customary is in atmospheres. Volume is in liters or cubic decimeters. And volume in the customary system is the gallon. The beauty of the metric system is the use of prefixes to show increasing or decreasing size. Just as we'll use dram, ounce, and gallon to show increasing volumes, the metric system uses a system of base units, that would be the meter, liter, gram, and prefixes to adjust their size by factors of 10. You'll have things like mega, which is 1,000,000 times larger than the base, kilo, which is 1,000 times larger than the base, and our base is just 1 meter, 1 liter, 1 gram, 1 second. You'll have deci, which is 1/10 of a base unit. Centi is 100th of a base unit. Milli is 1,000th of a base unit. Micro is 1,000,000th of a base unit. Nano is 1 trillionth. And pico is 1,000 trillionth of a base unit. Most of the conversions that you're going to need in an average chemistry course are going to be things like kilo, which is 1,000 base units, deci, 10 deci make up one base, 100 centi make a base, like 100 cents make $1. Deci is related to like a dime, takes 10 of them to make $1. And milli, there's 1,000 milli to a base and 1,000,000 micro to a base. And these set up what we call our conversion factors, which allow us to convert between our different units in the system. We can use a metric staircase to simplify our conversions. You can recreate the staircase on your own using the mnemonic device King Henry danced before drinking chocolate milk. And then he used what's called decimal hopping to determine our new converted unit. So here's our metric staircase. We have our base unit and our deci unit, and we're just going to be moving the decimal to the right or to the left. So let me show you how this works. If we have 125 millimeters, we're going to start standing on that milli step. So we're going to write our 125 right here. Now, as we go up, we want to go up to meters. We're going to move our decimal point to the left. So 125 millimeters is going to be 12.5 centimeters, or 1.25 decimeters. And if we go back all the way up to the base unit, that third step, it's going to be 0.125 meters. And remember, don't forget to put that leading zero before your decimal point. It makes that decimal point clear. So if we're going to do 1, 2, 3 hops, we're going to move our decimal point 1, 2, 3 times. Let's try another one. Clear this out. Let's take 125 meters to kilometers. So now we're standing here at 125 meters. And we want to go up here to kilometers. So we're going to go one step up. We're going to make that 1 point to the left, 12.5 deca meters. Go one more point, 1.25 hectometers. One more jump up, 0.125 kilometers. Let's try another. Clear these out. Okay. We're going to go 250 milliliters to liters. So now we're going to try it just standing on our step. We've got 250. We're going to move the decimal 1, 2, 3 times to take it to liters. So we're going to move it 1, 2, 3 times, 0.25, 0 liters. Okay, let's take a moment and you try a couple of these. Remember, if you're moving up the staircase, you're moving your decimal to the left. We didn't practice any of these, but if you're going down the staircase, you're moving it to the right. So just take a moment and try a couple of these. Okay, you should go fast, so let's see how you did. We have, I like to put my commas in to make it a little clearer, 17,000 meters to centimeters. Well, if we're going from a base a meter and we're going down, we're going to go to deci, we're going to go centi, we're going to be going down 2 steps, so we're going to move the decimal to the right 2 times. So we've got 1, 2, 3. To go to the right 2 times, we're going to add 2 more zeros. Okay, we're going to convert millimeters to kilometers. So this is a big jump. So if we look at our staircase, we're going to be starting here at millimeters and we're going to go all the way to the top. So we're going to go 1, 2, 3, 4, 5, 6 to the left. So I'm going to go 1, 2, 3, 4, 5, 6, and we're going to get 12 kilometers. I hope this decimal hopping helped. In our next video, we're going to address how to do this mathematically using ratios and scientific notation to convert between units. I hope this quick little video on decimal hopping helped. Remember, stay curious, be safe, and practice kindness. Have a lovely day.